Okay, dear students, hope that we were discussing about some of the physics concept, the ray optics concept, especially the compound microscope in the previous class. That is what, especially the magnification case in case of compound microscope. So as I said you before in the previous class, the magnification of a compound microscope is nearly equal to 1000. And my dear students, even I said you that the compound microscope is just used to see the tiny particles, that is what the microorganisms. So just to see them very distinctly and separately. That's why we use a compound microscope. But even though with that we are just moving towards the usage of this telescopes also. You know that telescope is also an optical instrument. As we just did in case of a compound microscope, then we just got the two cases, whereas one case which is related with the object, the image is formed at the least distance of distinct vision, and another one case where the image is formed exactly at the infinity. So that we got two different equations for the linear magnification. One is m is equal to minus L by f naught into d by f e, and another one is m is equal to minus L by f naught into 1 plus d by f e. So my dear students, whereas these two equations exactly shows you that they have the negative sign, whereas the negative sign shows you that the image or the final image which has been formed is inverted and it is highly magnified. My dear students, so as we just said, so that for the observing of the microorganisms, we are using a compound microscope, as you might have already observed the first PUC in your biology laboratory. So now we are just moving towards discussion of the telescope, and we are just observing the ray diagram, that is how the image is going to be formed by the telescope. Then first let us define what is telescope. So simply we can define that telescope is an optical instrument. Telescope is an optical instrument. Okay. Then why we are using a telescope? So my dear students, to see the objects distinctly which are very far away from us. Dear students, it is used to see the distant objects very clearly, distant object separately, distant objects clearly and distinctly. So my dear students, I can say that it is an optical instrument. It is an optical instrument. It is an optical instrument used to see the distant objects clearly and distinctly. Yes. So that here, when we come towards the case of this telescope, we have two different types. One is said to be the refracting telescope and another one is said to be the reflecting telescope. Dear students, when we come towards this refracting and reflecting telescopes, whereas reflecting telescope is said to be the one which is having more advantages than that of this refracting telescope. To know clearly about this refracting and reflecting telescopes, first we should know where we people are just using a telescope. You know that my dear students, we use a telescope just to observe the heavenly bodies, right? We can say that it can be used to observe the planets, it can be used to see the sun and stars. So similarly, so that this telescope is of two types. So that types of telescope. So what is the first type of telescope? That is said to be the refracting telescope. Dear students, again the refracting telescope is divided into two types. We have two more types of refracting telescope. What are those? The first one is astronomical telescope. So astronomical, this exactly tells you that we are using the optical instrument to observe the stars, planets and sun, that is said to be the Astronomical Telescope. And even we have the telescope that is said to be the Terrestrial Telescope. What is this Terrestrial Telescope? You can observe the large distant planet, that is what the trees and the objects which are present on the Earth's surface. Then we have the second main type of the telescope called as reflecting telescope. When we come towards the reflecting telescope, again it is having the two different types. One is said to be the Newtonian telescope. One is said to be the Newtonian telescope. And the second one is said to be the Cassegrain telescope. So, but now in your syllabus, we are just going to discuss regarding the Astronomical Telescope and Cassegrain telescope. Now let us move for the discussion of the Astronomical Telescope. As I said you already, my dear students, Astronomical Telescope is an optical instrument which is used to see the distant planets, stars, sun, etc. Then, what is how to construct this astronomical telescope? As you know, in case of a compound microscope, we just observe there we have two lenses. Similarly, in this telescope also, we are having two lenses, especially for refracting telescope. First, you should write the astronomical telescope is a type of refracting telescope which is used to observe the distant planets, stars, sun and etc. See, an astronomical telescope also we have mainly two lenses, whereas one lens with shorter focal length and less aperture, and the other lens with larger aperture and greater focal length. Dear students, you might have observed in a compound microscope, we kept the lens with the shorter focal length, that is what the less aperture towards the object, and the lens with the greater aperture towards the eyepiece. But here, in case of telescope, we are just reversing it. Why? Because here we are going to observe a very distant object. It means if the object is at very far away distance from the lens, you know already, if the distance is very far, so that we can consider that distance as infinity. So that if the object is exactly at a very larger distance, or the object is exactly at an infinity, then what kind of rays emerges out from the object? You know that parallel beam of light comes from the far away object or the farthest object or the object which is at infinity. Then to allow those parallel beam of light to fall on a lens, we should have a lens with greater aperture. So for that reason, just to observe the object by the lens, so we are using a lens with a greater aperture as an objective lens in case of astronomical telescope. Dear students, here when we come towards a part of construction, here I am just using two different lenses. So the lens, I am just going to write the diagram. We have the two lenses. Those two lenses are called as convex lens. So the two convex lenses are placed coaxially, so that the axis of one lens is parallel to the axis of another lens. So that the two lenses are placed coaxially to each other. Now, both the lenses are having an optic center. So through the optic center, I am going to pass an line that is said to be the principal axis. Dear students, you can observe that here we have one lens. So that this lens is with greater aperture. So as well as it is having a greater focal length. Whereas here we have another one lens which is having less focal length and the less aperture. So here the lens with the greater aperture is considered as the objective lens with optic center O, and as well as the lens with the lesser aperture is called as the eyepiece, whereas this eyepiece is placed towards the observer and the objective lens is placed towards the distant object. Now the eyepiece is the one with the optic center A, whereas these two lenses are exactly arranged on the ends of movable sliding metal tubes. Right. And one thing you should know, the distance between this objective lens as well as the eyepiece can be arranged with the help of rack and pinion arrangement. Dear students, so first take an astronomical telescope, afterwards take the definition that it is a type of a refractive telescope which is used to observe the distant planets, stars, sun, etc. In the next line, take out the heading construction. In that part, write it. It consists of two convex lenses placed coaxially at the outer ends of the two sliding metal tubes. Full stop. The lens with the greater aperture and the greater focal length is called as objective lens, and the lens with the lesser aperture and the less focal length is called as an eyepiece placed towards the observer. Full stop. The distance between this objective lens and the eyepiece can be arranged, can be rearranged, can be adjusted with the help of rack and pinion arrangement. Hope you return this construction. Now let us see the working principle. So before going to write the working principle, we are ready. Ray diagram. So now let us observe the ray diagram and also the working principle. First let us write the ray diagram. So we just completed the construction part and now let us write the ray diagram. Right. So just I said you already, the object is at infinity. What happens if the object is at infinity? Parallel beam of light. See, I am writing a parallel beam of light is going to incident right on the lens, so it is having larger aperture. So I am just considering one ray which is passing through the optic center. So whereas another one ray which is parallel to the ray passing through the optic center is going to fall on the lens. After refraction, it is going to meet at some point. Whereas you can observe it clearly. You know, if the object is at infinity, then obviously that the convex lens is going to form the image at principal focus. Right. Then, whereas the image formed is inverted and it is real. Real and inverted. Now, let us see this. See here, it is inverted image we are observing. But this inverted image, it should be erect for us to observe the image clearly. So what we are just doing, we are just going to place another one lens called as eyepiece. Now let us see that, let us give the name. So now this is said to be A dash, B dash, right? Because A is an object which is at infinity. Now this is a point where the image is formed. That point is called as principal focus because the rays of light are coming from infinity. Obviously the image is formed at focus. So that this is called as the principal focus. So I am just going to write it as principal focus. Now, dear students, now listen carefully. That here again the image formed by the objective lens acts as an object for eyepiece. Right. Now the distance between the principal focus and the optic center is called as the focal length of objective lens, written as F naught. Now the distance between this image of the objective lens and the image of the objective lens and the eyepiece is adjusted such that of the first lens should be exactly at the principal focus of eyepiece. You have to arrange one topic no distance now. The distance between this object and this image, that is lens, is adjusted with the help of wrap-on pinion arrangement, so that the distance should be in such a way that this object is exactly at the principal focus of eyepiece. However, this principal focus is common for both this objective lens and it is common for the eyepiece. However, the distance between the optic center and the principal focus is called as the focal length of eyepiece, written as Fe. Now, the rays of light from the object A', B' falls on eyepiece and finally it forms image. See, we have the initial object at infinity, then after refraction to the objective lens, we got the image at principal focus. Then what we did? So we have arranged the distance between the object and the lens so that this object is exactly at the point of the principal focus of eyepiece. Then what we get? We see here the object is at focus right now. If the object is at focus, you know that image will be exactly at the infinity. So now I am using two different rays. One ray which is parallel to the principal axis. It refracts and passes through the principal focus. Now another one ray I am using, the ray which is passing through the optic center. So it passes out without refraction. So my dear students, you can observe it very carefully that these two rays are parallel to each other. These two rays are parallel to each other. So parallel rays, they are not going to meet anywhere. So then here the observer is. So that for the observer, if I just extend these two refracted rays, so that the image is formed at infinity. Take down this ray diagram. So now it is like the working principle. Yes, now let us see the working principle. So take down that, I will just say it. The parallel beam of light from the distant object falls on the objective lens of the telescope, it forms real inverted image at the principal focus of objective lens. Full stop. In the next line, the image formed by the objective lens serves as an object for eyepiece. Full stop. Next line, the distance between the object and the eyepiece is arranged in such a way that the object is exactly at the principal focus of eyepiece. First up, last one, the final image is formed at infinity. Yes. So this is a working principle of astronomical telescope. So my dear students, it's very easy so that you can observe what is the formula for the magnification and also you can even explain the length of telescope. What's the length of telescope? It is the sum of F0 and Fe. It is the sum of F0 and Fe. I am just writing that the length of the telescope is equal to F0 plus Fe, that is focal length of the objective lens plus the focal length of eyepiece. In the next line, what is the magnification of a telescope? Now I am just writing the formula for the magnification of telescope. M is equal to F0 divided by Fe. F0 divided by Fe. Hope you got, my dear students. So that we finally got the expression for the length of a microscope, telescope and the magnification of telescope. Here we are not going to derive as we did in case of compound microscope. There is no derivation for this. We just directly enter the formula for the length of telescope and magnification of telescope. But definitely you will get the ray diagram into an examination. And also, dear students, remember that the working principle and also the construction of the principle of this astronomical telescope. Then after this astronomical telescope, now let us move towards the discussion of Cassegrain telescope, that is said to be the reflecting telescope. So what is a reflecting telescope? As I said you before that already, terrestrial telescope is also a refracting telescope, but we used to see that the objects which are present on Earth, like the houses which are present very far away from us. So for the construction purpose, we'll use that kind of telescopes, which was used by the engineers and all. And my dear students, now we are just moving towards the discussion of a reflecting telescope. As I said you before, reflecting. What does that reflecting indicate? See, the telescope, if it is made of the lenses, it is said to be the refracting telescope. If the telescope is made up of a mirror, that is said to be the reflecting telescope. How, my dear students, you know that when we come towards a reflection case, we have observed two kinds of spherical mirrors. One is concave mirror and another one is convex mirror. So by using two mirrors, that is said to be the convex and also the concave mirror, we are going to just construct a Cassegrain reflecting telescope. Take down the heading that explain the construction and working of Cassegrain telescope. Explain the construction and working of Cassegrain telescope. Yes. Now let us see the ray diagram for this Cassegrain telescope. As I said you before, Cassegrain telescope is a reflecting telescope. So which is having mirrors. So my dear students, first I am going to write an halo concave mirror and hollow concave mirror with a pinhole exactly at the midpoint of that concave mirror, right? So whereas this concave mirror, this hollow tube shaped concave mirror is having a pinhole exactly at the midpoint. This mirror is called as primary mirror. This mirror is called as primary mirror. Now, at this opening, at this hole, we are going to place an eyepiece. So that the observer is present at this position. See the image, right? Now, inside this, we are going to place another one convex mirror. So whereas this convex mirror is exactly at the principal focus of this primary mirror. This concave mirror is called as secondary mirror. It's called as secondary mirror. Where we placed at the principal focus of this primary mirror. That the concave mirror is that primary mirror is that other focus point convex mirror place ಮಾಡ್ಕೊಂಡಿದ್ದೀವಿ. ಹಾಗಾದ್ರೆ now let us see the ray diagram. See, already I said you that the telescope is used to observe the very distant objects. Very distant objects means the object is very far away from the source, so very far away from this telescope. Very far away indicates that maybe the object is at infinity. So that the far away objects always gives you the parallel beam of light rays. So that the parallel beam of light rays falls on the primary mirror. So when these two rays, when the parallel beam of light falls, when the parallel beam of light falls on the concave mirror, you know that it converges at principal focus. Whereas they reflects because infinity in the mirror rays ಏನಾಗುತ್ತೆ principal focus ಹತ್ರ meet ಆಗುತ್ತೆ. They meet the principal focus. But at principal focus, what we kept? We kept a convex mirror so that before converging at a principal focus that reflects back from the secondary mirror. I am repeating again, my dear students. See that here we have two reflecting rays, two parallel beam of light. So that what the parallel beam of light are coming from a very distant, very far away object. Whereas this parallel beam of light is going to fall on the primary mirror. So you know that the mirror reflects the incident beam of light. When it reflects the incident beam of light, so that if the parallel beam of light is incident on a concave mirror, after reflection it should converge at a principal focus. It should converge at a principal focus. But here at principal focus we kept another one convex mirror, so that before converging there falls on this convex mirror such that it reflects back. It reflects back and passes through the hole, and reflects back and passes through the hole, so that the image is observed by the observer. The image is therefore the reflected rays are going to pass through the eyepiece, and the observer is going to observe the image of the distant object. So that write the construction. So after writing off this ray diagram, so take down the construction part. So that Cassegrain telescope consists of two mirrors. Full stop. In the next line, the large parabolic concave mirror with a narrow hole at which eyepiece is placed. Full stop. This mirror is called primary mirror. Next one. At the principal focus of the primary mirror, the secondary mirror in bracket convex mirror is placed inside that primary mirror. Full stop. In the next line. In the next line. In the next line. So the primary and secondary mirror are adjusted in such a way that the clear image should get at the eyepiece. So you can write the last point or you can avoid it, no problem. Just you can write the starting 3 points that helps you. So now let us write this working also, working principle. As in the working principle, when a parallel beam of light rays falls on a large concave primary mirror, so it reflects and converges on the secondary mirror placed at the principal focus of primary mirror. After reflection from the convex mirror, they falls on the eyepiece and the images form. Full stop. See, now what type of image we got, that we should know here. Dear students, the image which is formed here is always inverted. Right? See, my dear students, I can say easily that the image which is formed is highly magnified, which is highly enlarged, which is inverted. Right? Note down the last point. The image formed is inverted with respect to the object and highly magnified. Full stop. Hope you got you written the working principle and also the construction related to the Cassegrain telescope as well as the ray diagram, which is helpful for your examination. My dear students, so as I said you before that the reflecting telescope is having very more advantages. It is just we can say that the reflecting telescope is more advantageous compared to the refracting telescope. Why we just said, yeah, reflecting telescope is most advantageous than refracting telescope. See, construction of the refracting telescope, that is what arranging of the lenses is very difficult compared to that of the arrangement of this mirrors. So that it is very fixed, right? There is no need to arrange with the help of rack pinion arrangement and all. Exactly, it is already fixed and easily we can observe it. So that the construction is easy in case of which one? Reflecting telescope compared to that of this refracting telescope. That is the first point. As well as in case of refracting telescope, so that you know when the ray of light is going to bend from different medium, so that they bend. different wavelengths of light is going to bend at different rate. So if they are going to bend at a different rate, then exactly I can say that, my dear students. So ಏನಾಗುತ್ತೆ ಡಿಫರೆಂಟ್ ರೇಟ್ ಅಲ್ಲಿ ಬೆಂಡ್ ಆಯಿತು ಅಂದಾಗ ಅಲ್ಲಿ ಕಲರ್ ಇಮೇಜ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಇಟ್ ಮೀನ್ಸ್ ಕ್ರೋಮ್ಯಾಟಿಕ್ ಅಬರೇಷನ್ಸ್ ಇರುತ್ತೆ. ಬಟ್ ಹಿಯರ್ ಇನ್ ಕೇಸ್ ಆಫ್ ರಿಫ್ಲೆಕ್ಷನ್ we are not going to observe any kind of chromatic aberrations. So the reflecting telescope is free from chromatic aberrations. Not only that, the reflecting telescope is free from spherical aberrations. Therefore, the construction is of low cost. So that the reflecting telescope is of low cost, whereas refracting is of high cost. And another one thing is, the main two important points are there. My dear students, the resolving power of the reflecting telescope is very, very high compared to the resolving power of refracting telescope. And the last point is that the final image is very bright in case of a reflecting telescope, but in case of refracting telescope, the final image is not that much bright. So that why we used to call that the reflecting telescopes are more advantageous than refracting telescope. One is this free from chromatic aberrations, one is this free from spherical aberrations. It is of very low cost, the construction is very easy, and that is what the arrangement between the mirrors is very easy. And the next one is the resolving power is very high, and the final image is very bright in case of this reflecting telescope. Dear students, so in this chapter almost all we covered that the refraction and definition of refraction by spherical surfaces, refraction by convex spherical refracting surface, refraction by concave spherical refracting surface, refraction by convex lens, refraction by concave lens, lens maker's formula, and also the relationship between capital R, N, U, V, and even we just discussed some concept which comes under that refraction to the prism and the refractive index of a prism, and also even we just discussed the optical instruments. Before discussing of the optical instrument, we observed that the total internal reflection, critical angle. So even with the total internal reflection and the critical angle, we just gone through the explanation of the mirrage, optical fiber, and also even we have discussed that the brilliance of a diamond and all, and afterwards we just moved towards the discussion of an optical instruments, that is to be the simple microscope, compound microscope, their linear magnification, and even we discussed that the telescope concepts. These are all the things that what we discussed in this ray optics chapter. Now we are just moving towards the discussion of the concepts which will come under, that is what the numericals which will come under this ray optics chapter. Dear students, definitely you might get the lens maker's formula as for your examination, and also that the combination of lens for your examination. With that, in the combination of lenses, while I am going to discuss over the CT and the need bits, there I will just give you some different formulas also. Even here also I just discuss some cases. What happens if F1 becomes equal to F2? What happens if F1 is greater than F2 and F1 is less than F2? These are all the concepts that we covered in this chapter. Now let us move towards the solving of numericals. One thing is, I will just read out the question. So just take down the question by just pausing the video, and afterwards by observing the question, I will just try to solve the answer over on the board. Just put it down in the notebook. Hope you are very much clear to this. But for your examination, the important concept from the chapter is the refractive index of a prism. N is equal to sin of A plus C by 2 divided by sin of A by 2. And another thing is that the total internal reflection, critical angle, and one is lens maker's formula, relationship between R, N, U, V. And the last one is optical instruments. These are all the important questions. These are all the important 5 marks questions that you might have that you may get exactly in your final exam. Now let us move towards numericals. For the heading numericals, the first question I am going to read it out. So just pause the video and write it down. So a prism of angle 60 degree produces angle of minimum deviation of 40 degree. What is its refractive index? Calculate the angle of incidence. Calculate the angle of incidence. Yes, I hope you written the question. Now I will just move on for solving of the answer. See, I am just moving it. See, questions now so many of you people are not writing the questions. Some of you, not all. Some of you have not written the questions. write the question, of course I will solve it. So I will just read the question once and I will just write given values, and of course I will move on for solving it out. So a prism of angle 60 degree. What is the angle of a prism they given? The angle of a prism is 60 degree. Yes, good. Write it down. A is equal to 60 degree. Produces angle of minimum deviation of 40 degree. What is the angle of minimum deviation? Capital D is said to be the angle of minimum deviation. The given is found to be equal to 40 degree. Then what we should calculate? What is the refractive index? And calculate the angle of incidence. We should calculate the refractive index, that is n is equal to question mark, and also even we should calculate the angle of incidence, I is equal to question mark. So these are the given values. That is what A and D are the given value, and the values that we should calculate is equal to N and I. Dear students, what is the formula required for this? So this numerical is exactly related to the prism. So we should calculate N, that is the refractive index. So what is the formula for refractive index of a prism? N is equal to sine of A plus D by 2 divided by sine of A by 2. Right. Now, see, let us substitute the value. N is equal to sine of, what is A? A is 60 degree plus D is 40 degree divided by 2, right? Or divided by sine of A is 60 degree divided by 2. What is this? 60 plus 40 is 100. 100 by 2 is 50. So N is equal to sine 50 degree divided by 60 by 2 is 30. Sine 30 degree. See, we know the value of sine 30, that is 1 by 2. How to write 1 by 2? It can be written as 0.5. But my dear students, here to solve this, you should keep the log book. See, I am just starting with the numerical part, so that still it may go within 3 days. So that is what 3 sessions it may carry on. So by the time you should place a log book, and also even you should place the calculator with you, right? So here, what is the value of sine 50? Open your log book. So hope you learned the calculation of log values. So in that, just go with the natural science. Open the natural science part, so that there you can observe the theta degree. So to the left corner, 50 degrees, 0 to 1, 2, 3, 4, 5 degree, 50 degree. So 50 degree. So 0 minutes again, 50 degree. So here you have 50 degree. So in the log, right? So here you have theta values system that 50 degree that you can have 0 minute. So 50 degree 0 minute so in that log book you will get the value of that is equal to 0.7660. 0.7660. Right. So we finally got the value of sine 50 with the help of your log book. So even you can calculate the value of sine 30 with the help of a log book, but even so there is no need to calculate because you know already that the value of sine 30 is 1 by 2. 1 by 2 can be written as 0.5. So 0.76 divided by 0.5. So that is equal to 1.5. Use your calculator. This time writing here you come the code directly on the board. Use your calculator and divide it, you will get 1.2. So that we finally calculated the refractive index of the prism. N is equal to 1.53. Then what is the angle of incidence? So now the angle of incidence I. So here we know that I is equal to A plus D by 2. I is equal to A plus D by 2. What is A? Here it is 60. What is D? It is 40 divided by 2. 60 plus 40 is 100 by 2, which is equal to 50 degree. So that you finally got that the angle of incidence is equal to 50 degree. So my dear students, we got the angle of incidence which is equal to 50 degree. Yes. So the simple numerical we have solved today. So get on the next question. Yes. The two lenses of focal length 0.20 meter and 30 meter are kept in contact Full stop. Find the focal length of combination and also calculate the power of the two lenses of the combination. So here the question was like this. Just pause the video and write the question. Now I am going with the second question. So here they given that we have two lenses. So one focal length is 0.2 meter. The first focal length f1 is equal to 0.2 meter and the next focal length f2 is 0.3 meter. So then we should calculate the focal length of the combination of these two lenses, as well as even we should calculate the power of the combination of these two lenses. These are the given values. So what is the formula for the combination of two convex lenses? 1 by f is equal to 1 by f1 plus 1 by f2. Even we can write it as f1 plus f2 divided by f1 f2. If I just take the reciprocal, so f becomes equal to f1 f2 divided by f1 plus f2. Right. Let us substitute the value. F is equal to 0.2 into 0.3 divided by 0.2 plus 0.3. Right. 0.2 plus 0.3, which is equal to 0.5. And there we should multiply 0.2 into 0.3. So easily you can write that the multiplication is equal to 0.6. Sorry, 0.06. Suppose if you face a problem, so no need to worry. 0.2 can be written as 2 by 10. 3.3 can be written as 3 by 10. 2 by 10 into 3 by 10. It becomes 6 by 100. 6 by 100 is equal to 0.06. Right. So that what is the total value? 0.06 divided by 0.5. So to write 0.5, it can be written as 1 by 2. 1 by 2, so it becomes 2 comes to the numerator, so 0.06 into 1, that is what 2 becomes equal to 0.06 into 2. Why? Because this can be written as 1 by 2, 2 comes to the numerator. See, it becomes finally f is equal to 0.12 meter. So finally we calculated the effective focal length of the combination of two lenses. So still we should calculate the power. It's for your homework. Just try to calculate the power in your home. So my dear students, so this is end of this today's session. So in the next session we are again moving with the numerical. So please keep a calculator and also that logbook with you. Thank you dear students.